Okay, before we go any further, it occurred to me recently that I actually skipped over something that will be quite helpful to you all as we go forward. And that's how to figure out from the periodic table what charges particular elements make, okay? And the basic idea is that on the far outsides of the table, the charge is a 1. But on one side it's a 1 plus, and the other side it's a 1 minus. So let's think about what's happening with the periodic table. The whole left 2/3 of the table are metals, and metals lose electrons. Electrons are negatively charged, so if you have something that's neutral and it loses some negative, then that means that what you're left with is a positive charge. So everything that's in the metals category of the periodic table is going to be a positive charge of some kind. Now if we start on the far left of the periodic table, okay, in the column that hydrogen is on top of, all the metals in that first column, the alkali metals, will all make a +1 charge. Okay, so lithium makes a +1, sodium, potassium, rubidium, all +1s. Okay, the next column over, the column that starts with beryllium, they all make +2s. Okay, so beryllium, magnesium, calcium, strontium, all +2s. Okay, and then we're going to skip over the transition metals for now, okay, because the transition metals are notoriously disorganized. Now we get across to the other side of the periodic table. Aluminum, we've got this pattern going of +1, +2. We keep going and we get to aluminum, and aluminum makes +3. Now this column where carbon lives, okay, carbon lives right here in the periodic table. This column, the best way to describe it is the top of a hill. Okay, we start with +1, we're climbing the hill with +2, we're climbing higher still with +3. So now the carbon group, we're at the top of the hill, and you can think of it as both +4 and -4, okay? But the real gist here is that we don't make any ions with this column. Okay, the carbon group doesn't make any ions. Right, this is important. It's just sort of like the top of the hill. So now we're going to come down, keep going to the right. We're going to come down the other side of the hill. So if we're at 4 and we're coming down the other side of the hill, the row that starts with nitrogen, they all make a -3. Okay, and if we keep going on with that pattern, the next row over, the oxygen row, makes a -2, and the halogens make a -1. And everybody below that will do the same charge. Okay, now let's talk about these other elements that I have written on the table here. Now if we start with carbon at a 4, and we stair step down to the left, we get aluminum's a 3, and we stair step down one more, zinc is a +2. And if we stair step down one more, silver is a +1. Okay, so noticing that pattern coming down the stair step to the left from carbon, we get +3, +2, +1. Okay, now here's where things get interesting. So copper can make a +1 or a +2. And then all 4 of these other guys, they all do the same set, but they can either do a +2 or a +3. Okay, but the ones that you can definitely rely on are basically anybody other than chromium, manganese, iron, cobalt, or copper. All of these other ions will make the same ion every time. Okay, and I want to make it clear that this row really doesn't do ions. Okay, so starting with the alkali metals, we go +1, then +2, we cross all the way over to a +3. We come down the other side of -3, -2, and -1 when we get to the halogens. The noble gases are noble. They don't react with anything, so they don't make ions. Okay, that's that far right column that's currently in green. Right, and then if we stair step down from aluminum, we're +3, then +2 at zinc, +1 at silver. And then this group of miscreants all make multiple charges. So I'm going to go ahead and just let this piece of video be self-sustaining, and we'll pick up where we left off on the next video with